So we're here to talk today about Angular 2 war stories. So what we're going to do is share with you our experiences about building and shipping Angular 2 apps into production. Now, a lot of war stories talks are about what people don't like about a framework or the problems they have. So we're not going to stand up here and complain about Angular 2 today, though, because we actually love it. So what we want to do is share with you what we learned along the way, and our goal is to save you time so you don't have to go through the pain we have, get you asking the right questions, and get some answers out to you. So I'm Adam Stephensen. I'm a solution architect and the general manager of SSW in Queensland, and I specialise in shipping enterprise web apps. And I've been building Angular 2 since it was in alpha and been working on .NET Core since it was in beta. So I've had a pretty fun year and a bit.
Hi everyone, my name's Duncan. I work with Adam in Brisbane, Australia as well. I'm a software architect there, and I'm one of the mentors at Fire Bootcamp Online, where we teach people Angular. And I've been really lucky over the last couple of years to just pretty much only do Angular 1 and 2, all in TypeScript, about a dozen projects all in production at the moment. And we've had a really lucky chance as well to go around doing a lot of teaching. We've probably taught about 1,000 people Angular 2 now, especially across Australia. And we get to do frequent code reviews and get into conversations with people about best practices and stare into what other people are doing and what we're doing. So hopefully we can share a bunch of that kind of experience with you today.
So what are we going to cover today? We're going to talk about what is Angular and why you should care about it. We're going to talk about Angular 1 and the upgrades paths to Angular 2. We're going to talk about module loaders and build systems, about TypeScript and IDE choice. We're going to cover CSS frameworks and widgets, which isn't actually as simple as it should be. And where the rubber really meets the road is we're going to talk about observables, RxJS and Redux. And this is where most people find the most pain when they're getting into Angular 2. So hopefully we'll help you out with all of those things. So what is Angular 2 and why should you care?
Before we jump into talking about Angular, I just want to take a walk down memory lane of putting applications in the browser. And it all kind of kicked off with JavaScript in '95, which was supposedly written in about 2 weeks, which is kind of funny because it's now kind of ruling the world. And then in 2002, we got XHR requests from the Outlook team at Microsoft, which was pretty interesting because it's the first time we didn't have to do page refreshes to get data. And then in 2006, we got jQuery, which was the first time we saw people like Microsoft and Apple and Google all agreeing to use the same library rather than rolling their own. 2008, we got the Chrome browser and the V8 engine. Things got faster, people getting more ambitious what they could do in the browser. 2009, we got Node, and we saw JavaScript on the server, but more importantly, we saw the Node package manager, which is kind of what we all use now to manage our packages on the front end. We got Knockout in 2010, but that's been knocked out. And then Angular came along and in 2010, so it's now like 7 years old. So they learned a lot being the most dominant framework over the earlier part of that, and a lot of that's kind of culminated in Angular 2. But then we saw React hit the scene in 2013, and that was really popular and is still hugely popular. We got TypeScript in 2013, but that was only really cool for the Microsoft kids, and none of the cool kids knew about it until Angular announced they're going to build Angular 2 in it, and then all the cool kids thought it was brand new, and now they like it. In 2016, we got Angular 2, and we saw JavaScript, like the ES6, the latest version of JavaScript, become kind of widely adopted. And it's like the biggest update to the language in 6 years. So there's a lot of goodies in there. But what you can't see on this slide is all the JavaScript churn, and which has kind of come to coining this term JavaScript fatigue, where no one person can stay on top of everything. And there's like broccoli and brunch and gulp and grunt and sausage.js or whatever. And there's a lot of stuff. And it's hard to kind of keep up with all that stuff. And it continues still. There's a lot of churn.
Did you just make up sausage.js? It wasn't in practice. Hey, it's not called Angular 2 anymore.
So I've been saying Angular 2 a whole bunch. They've just decided to drop the version numbers from their name. They're going to take on board semantic versioning. We're still transitioning like everybody else, so you'll still hear us say Angular 2 a whole bunch. But they want everyone to now just say Angular, not AngularJS, and which is good. It's going to be a little bit more evergreen. Hopefully there won't be as many breaking changes, and we won't have this kind of drama that we've seen going from version 1 to version 2 over like 2 years and all this versioning issues. So it's just going to be Angular, and we're going to see a lot more kind of version number changes.
Awesome. So Angular is a JavaScript framework, right? Well, it was. When the Google team released the first version of Angular, they said it was a superheroic JavaScript framework. The idea was it's going to be the best of the best JavaScript frameworks. But then when they released Angular 2, now they say one framework, mobile and desktop. Much more ambitious goal. What they're saying is, well, you're going to be able to write an Angular app and use any backend you want. And now not only are you going to be able to build web apps, but Angular is going to be the best choice for building mobile apps for iOS and Android. And you're going to be able to use it to build desktop apps for Linux, Windows, and OS X. So that's pretty ambitious. There was a big problem with Angular 1. If you're trying to build really big, complex apps, it was slow. If you tried to run it on underpowered mobile devices, you hit performance issues. So a real focus of Angular 2 from the team has been getting great performance, and they've done really, really well. Now we've got optimized code generation, so your HTML templates are actually turned into highly optimized JavaScript. There's universal for server-side rendering and SEO, so now the first page load is blindingly fast. We've got code splitting, so unlike in Angular 1, when you load the first page, it's downloading all the JavaScript. Now, when you load the first page, it just downloads the bundle of code you need for the first section. And as you navigate around the app, it'll actually just download the JavaScript as you need. The real reason I'm a big fan of Angular 2, though, is the productivity. You know, I'm hands-on tools during the day, and I run a couple of teams. And what I care about is adding value for our customers. And Angular 2 is amazing for that. So the component model makes composing your applications really easy. The template syntax is really simple but very powerful. And we've got Typescript now, which gives us, strong typing for our JavaScript. And the Angular CLI, which we'll talk a lot more about, it gives us code generation, but the awesome thing about it is it's a wonderful production build tool. Angular 2 is also a complete framework. Out of the box, you're going to get routing, testing, internationalizations, animations, accessibility, and a production build tool. So this means you're not having to go and find all of these components and wire them up together. They all come out of the box, and they're all updated along with Angular, so they all stay in sync, which is great. Angular is also the most popular framework. What we've got here is a Google Trends graph of the most popular front-end frameworks. We can see it's really a two-horse race between React and Angular is much more popular. But we're not in high school anymore, so why is popularity a big deal? Well, the most popular frameworks, there's more blog posts about them and more courses about them, so they're easier to learn. When you get stuck, there's more Stack Overflow answers. There's more libraries that work in with them. Okay? They're also kept up to date and they're updated more regularly. Okay? And that's, Angular 1 is being used in production for 7 years. That's like 140 years in JavaScript framework years.
So let's have a look at what some of the architecture around Angular 2. And we're not going to spend too long on this, but at the heart of it, you've got a component class, and this is where you'd put all your logic that will drive your HTML templates. And on top of this, you'll stick some metadata, and this metadata is what lets Angular know that this is this component class is an Angular component. And it also wires up your component class with your HTML template, and they're kind of married together in that way. And you could call this whole thing a module, so you'd be able to export this from a file and then import it into another file and share it around. And if you have properties and functions on the component class you want to share, then you can do event binding to be able to get access to those in your template. And if you've got also property binding, and if you've got events that are raised on the template like a button click, then you can do event binding to be able to listen for those in your component. And if you've got other directives or components you want to share on this HTML template, you can do that. And if you've got reusable logic, you could stick it in an Angular service and then use Angular's dependency injection to be able to share that reusable logic across your components. Once you've got one of these components, you end up with 2, 3, 4, or lots of components. You end up with like a component tree. So at the top of that component tree, you would have something like an app component, which really would just be for initializing your application. And then next up, you might have something like a to-do component here in red. And it's really just a container component that's about getting the to-dos and showing just the title. It doesn't really have much more responsibility. But it also is the parent component for 2 child components in this example. So imagine you have a to-do list component. It's just responsible for getting to-dos and listing them on the page, and a to-do input component that's just responsible for getting an inputted new to-do and adding it to the list. So you end up with this component tree, and it allows you to do a lot of cool things with routing and change detection and code splitting that Steve-O mentioned. But another big thing that happened in Angular right towards the end of kind of beta and RC was they released their own module system called NG modules. And this allows you to specify basically a section of code. And we're going to talk more about it today, but say this section of code has these dependencies. So you could say the whole thing is one big module. But what you can do as well is you can start splitting it up. And you could say my app module is one module, or my app component, and then this to-do feature per se is another module. And right now you can't do very much special with this as it is, but if you added something else like a home component and you made that its own module, then you can say, well, okay, I'm going to just download this home module to the page when I fire up the application, and all of the JavaScript in the other module I don't need until later, so don't bring it down into the browser. So the modules is a pretty big deal, and it changes the way you architect your applications. So Angular 2 itself is really easy. I never hear anyone complain about data binding or services or dependency injection or any of that sort of stuff. They all find that stuff really easy. But Angular 2 kind of forces you to confront modern web development. You kind of got to look it in the face, and you're going to have to learn a few things when you do it. You're going to need to learn to use Typescript. You're going to need to learn a bit of reactive programming with RxJS. And you're going to want to have a really good understanding of modules, including JavaScript modules and Angular modules and module loaders and module bundlers, and we're going to talk a lot more about that today. So in summary, what is Angular and why should you care? Angular is super fast. It's arguably the fastest front-end framework at the moment. It's cross-platform. You'll be more productive with it. It's a complete framework. It's enterprise-friendly in the sense that, a lot of our clients, we're a dev shop, we build things for people. They come to us asking for Angular. We don't have to do any hard sell. Even in Alpha, we had people from government agencies wanting to start building in Angular 2. And you're going to be more ambitious, which is really the big point, isn't it? You get more features with a new framework, and you're going to be wanting to build, bigger and better things, and you can do that much more easily.
So let's talk about Angular 1 versus Angular 2. The choice of frameworks is a really big deal. When you're choosing a new framework for your team, this is something that your company is going to be invested in for years to come. And it's more than that as well. It's a personal choice. So this is, it really relates to your career. This is what you're going to be a specialty. This is going to be your specialty. You're going to spend a lot of time writing in this new framework. So framework choice is a really big deal. It's easy to choose a new framework when you're starting a new project. Okay? But what if you've already got a feature? What if you've already got an Angular 1 application and you're just writing a new feature? What are your options? Well, here's something I want you to think about. Every line of Angular 1 you write today is technical debt. Okay, so if you're going to spend the next 6 months writing Angular 1 code, somewhere down the track, you've actually got to pay that off, and you've got to come back and you're going to have to upgrade that Angular 1 code to something new. So we really make it a priority to try and minimise the technical debt that we're adding into our solutions and get writing Angular 2 as quickly as possible. So what are the options for doing that? If you've already got an Angular 1 project, most people see the options as do a rewrite or upgrade. And let's have a look at what the options around those are. Well, if you're upgrading, you can have Angular 1 and 2 in the same project using something called the upgrade adapter. We really don't recommend it though. On the plus side, it means you can start writing Angular 2 today, but it's a huge refactor. There's big performance issues, and it's actually a big learning curve. So there's not only are you introducing Angular 2 and all the Angular 2 concepts, there's additional complexity in having them all merged in together. What we think is a much better option is to start writing Angular 1 like Angular 2. So if you can start TypeScript today in your projects. You can actually start using components from Angular 1.5 to new. You can start using components and add a module bundler into your system. So the benefit of this is it's low risk. You're already learning the Angular 2 concepts, and it's a better, faster future path to rewrite. The downside is that you're not actually writing Angular 2. You're just writing Angular 1 using Angular 2 concepts. It's going to take you about 3 times as long to do the migration, but a lot of our customers like this because it's a safer path. What I know most of you in here are doing, or what a lot of devs like doing, is getting approval for a big bang rewrite. That's heaps more fun. We're going to go file a new project and we're going to go and rebuild the thing we've already got and we're going to build it in Angular 2. We think that's a terrible idea. Obviously it's massively high risk. You are now building a new application in Angular 2 while you're maintaining your old application. You're duplicating code you've already got and introducing bugs as you rewrite it. And you're just recreating the problem. And your boss knows that in 4 years you're going to be going and asking for funding for another big bang rewrite. What we're trying to get people to think about doing is rewriting into smaller apps. So an example of this is when you've got an Angular 1 application, you extract out the authentication, and then you can start building another separate, smaller application for just new features. Okay? So the benefit of this is it means you can start writing Angular 2 today, but it's much easier to get approval because you're not getting approval to rewrite anything. You're just getting approval to start building new features in Angular 2. And you never have to do another big bang rewrite. Somewhere down the track, you might start moving the features and the older functionality into new, smaller apps. The downside is you're adding a bit of extra complexity with DevOps overhead. And this can be as easy as, so we've got a big timesheeting solution that we worked on, and it's got thousands and thousands of lines of Angular 1, and it's all sitting on top of ASP.NET. So the easy solution for that project was, we added another Razor view, and we added Angular 2 into the project, and the Angular 2 sits on top of another Razor view. So now there's a page refresh when you're navigating from the Angular 1 features to the Angular 2 features, but we're building modern software. So we think that's a much better option for people.
It's actually been a really interesting experience for me. Last year I had the chance to work for a company, and we built 3 small Angular 1 apps, and they were all separate apps deployed separately, and there was some DevOps overheads with their auth service and stuff, and they styled them all to look the same. But the position they're in now is they're going to make a 4th small app, and they can write it in Angular 2, and they can do a greenfield project, and they don't have to touch their Angular 1 code, which we only wrote last year. It's perfectly awesome. It's nothing wrong with it. So now they can make the next section of it all in Angular 2, and they're not thinking about rewriting or any of that sort of stuff. So, it's an interesting concept. If you're sitting here at the moment and you're thinking, what are we going to do with our Angular 1 code? Are we going to rewrite? Are we going to merge them together? It's worth also throwing into the mix to think, is there a way that we can just write a smaller app to kind of get around and do things differently and not end up in the same position?
So when we're thinking about upgrading or rewriting, Angular 1 is technical debt. It's 3 times the effort to migrate slowly, but it's a lot safer. But really, we think, the best strategy in most of the situations we've come across is to start writing new, smaller apps.
Cool. Let's have a talk about module loaders and build systems, which is a really big part of any, front-end application at the moment, and in particular for Angular. So one of the big problems we had with Angular 1 is that we had these huge downloads. You have to get the entire application into the browser before you can start it up. And we hand-rolled these build systems with Gulp. We would have a 1,000-line Gulp file that would crush down the package to try and make it super small. But our apps were still slow. We might still have an application, it wasn't uncommon for a big one to take up to 5 seconds to load that initial state. So this is where having a module bundler can really help you, and is a big transition from going from 1 to 2. JavaScript used to be such a simple world. You could really just get started with one script file on an index HTML page. But so the simplest way you could do Angular 1 today would just be to get an angular.js file and a HTML file, and you can start going. That's the simplest way to do Hello World. The simplest way to do Angular 2 Hello World at the moment is to use the Angular CLI, which we'll talk about later, and you get this. So this is just to put Hello World on the page. And I'm not telling you this to scare you off, I'm just saying the state of affairs. And it's 350 megabytes and 48,000 files. And all of it's in the Node modules folder. It's your third-party dependencies. And you can't stick 48,000 files in the browser, obviously. And a lot of people say this thing, Angular's terrible, why would you want to use it? But it's the same state of affairs for any front end, at the moment. You've got lots of dependencies you pull into your Node modules. But you can't, go through and cherry pick out of those 48,000 files manually and then go bundle that up. You need a build tool. So you're going to need to have a build tool to be able to deal with this. And to have a build tool that you can use in the modern environment, you're going to need to be able to declare everything every file needs, so you can go read through all of that and understand what you can take to ship to the browser and what you're not going to take. So at the heart of that is ES6 modules, and that's the import and export statements. So for example, you'd have this math.ts file, and you'd use this export keyword. So you would export this sum function out of this file, and then you can use the import keyword in another file, and you can import that sum function. So the cool thing about this is once you declare everything with the import and export statements, you know everything this file needs, and then you can start doing some of these build tools. But one of the problems that Angular faced near the end of their kind of big journey into Angular 2 was you'd end up maybe having 20 of these import statements for every little bit that each file needed. You know, if you use an if statement with Angular and ngIf, you'd need an import for it. If you did a for each with ng4, you might need an import statement for it. So this is going to be a little bit crazy, and we want to do some other things. So they came up with their own module system, which I first thought, oh, you guys are insane. Like, we've got a standard, we've now got JavaScript modules, but I've come around to like it because it saves you on a bunch of those import statements to be able to say, okay, for this area of code, these are the dependencies. And it also helps you wire up that code splitting. But what's really good once you've got all these things, you can kind of draw a dependency graph. You can say this JavaScript file has a dependency on this TypeScript file and this Sass file and this CSS file and so forth until you build up this dependency graph. And you can pass that into a module bundler like Webpack or the System.js builder, and it will then be able to bundle it up for you. So you could make just one big bundle like this and stick all of your JavaScript in there to send to the browser. You can get a little bit more ambitious and start separating it out into like a vendor bundle, because that doesn't really change very much for all of your third-party libraries. But then you can start getting more advanced and you can say, okay, I'm going to lazy load this bundle or do code splitting and end up with multiple of those. So this is a big part of the Angular 2 journey for us, definitely, is moving towards this new way of bundling up our applications versus gulp. The other problem is that currently we compile templates in the browser into executable JavaScript. What do you guys think would be the problem with that? Who can help me out? Performance, yeah, it's going to be slow. And also you've got to download like a little 200 kilobyte compiler into the browser. And this is what we did with Angular 1. It's how, you know, Angular 2 for a lot of people at the moment's working. But this big feature that they've been working on that you can use now, AOT or ahead of time compilation, is about being able to compile those templates offline. So in Angular 1 at the moment, what you do is you make an XHR request, you get the HTML template, and then you parse that in the browser. It's the only place it can work. And then you make some DOM, and then you get your executable JavaScript and you run it. But in Angular 2, what you can do is you can get that same HTML template, but you can be offline. You can parse that with Node, and then you get your executable JavaScript, and you can pass that straight to the browser. So now you don't have to download this, you know, compiler, and you don't have the performance hit of having it there in the browser as well, so things get a lot more faster. So this is really one of the two big features, you know, for Angular 2, this and the code splitting that, you know, evolves around all their module system and the module bundling that you've got to get your head around. So it's not the only thing, the AOT stuff. There's also inlining modules and tree shaking and minification, and there's a bunch of stuff there. And the tree shaking is a really interesting idea that you can kind of go through your application and shake out the code you don't need. So if you're not using the Angular router or you're not using the reactive forms module from Angular 2, then you won't actually get that pulled into the bundle that you ship down to the browser. So big emphasis on performance.
So what you're saying is, to be able to ship my app, I need to copy fonts, compress images, lint my TypeScript, compile my lesson Sass into CSS, compile my TypeScript into JavaScript, minify it all, bundle it, run my unit tests and end-to-end tests, and now I need to run AOT compilation, do tree shaking, and then build separate bundles. That's a lot of work. Mm-hmm. Yeah. So it's getting really complicated and time-consuming to roll your own build process. So my first Angular 2 project was pretty cool. I was doing Angular 2 in alpha and .NET Core when it was in beta. So that's a bit of a... And I was really proud of myself. You know, I was a build tool ninja. I wrote this 800-file gulp file to go through and do all of those tasks. Okay? And, you know, so it's doing all of that stuff, but then we had a big issue with the Node modules folder. So we needed all of these packages, and we downloaded the Node modules. And there was 48,000 files in that Node modules folder. So when we shipping off to a test environment was pretty easy. You just copy the whole app over there and it runs. But shipping it to prod, obviously you don't want to copy all those files. So we had a file that just specified the files out of Node modules that we needed, and just those ones got copied across. And there's a few of you in the audience going, "You're an idiot. You should just use Webpack." And we'll come back to that. But it was kind of my first epiphany. And that's kind of the moral of the war story here, is that you need to get your head around module loading. You know, it's not Angular anymore where you're just sticking a script tag on your index.html. Okay, your angular.min.js has a dependency on 10 files, and they might have another dependency on another 10 modules. What you really need a module bundler that can do what Duncan said, and it can actually understand your dependency graph. And when you build, it can go out and just get all the bits that you need, and it can bundle them up into the bundles that you need them to do. So that's a really important concept we want you to leave and get your head around. And, and we got around it. So we ended up going and we had the gulp file, and then so we went and got the system.js builder, and then that actually went and analysed all of our dependencies and actually built our bundles for us. So, but then I ended up with like a 900-line gulp file, and everyone was going, gulp's not the way to go, there's better options. So we went and checked out Webpack. And Webpack's an advanced module bundler and has a lot of other features as well. And we checked out the Angular CLI, which is a command line tool that'll also do your production build. Now, so Gulp, it's a lot more work to use Gulp, and we don't recommend it. It's great, it's very popular with Node, but it's not the best tool for packaging your application for the web. Webpack is awesome. So Webpack has advanced module bundling. It's the most popular module bundler around. You can get it to do tree shaking, and it has really excellent plugin support. Now, the drama, what happens with Webpack, though, is it's a big investment in understanding. It's complex, and what happens on most teams is they go, you seem to be good at Webpack, you're going to be the Webpack specialist, so you're now the Webpack guy. Is there any Webpack guys in the audience? There's a couple. Look, being the Webpack guy isn't the coolest job in the world, but it's heaps cooler than being the Crystal Reports guy. The downside of Webpack is that you need a Webpack guy. It is complex. So then there's the Angular CLI. And now the Angular CLI is a command line tool that we can use for code generation. We can also use it for generating our builds. And it uses Webpack under the covers now, which is great. So we can actually use the command line to actually create application, we can do code generation, and it'll do our production build for us. It's developed in lockstep with the Angular style guide, so the code that it generates is directly in line with the best practices that the Angular team recommend, and it wires up your unit tests and your end-to-end tests out of the box. So we're big fans. The downside of it is that while it uses Webpack under the covers, you can't customize the Webpack build at the moment. But that's on the way. So let's have a look at what the Angular CLI is like to use. So I can jump out and I can go ng new CLI demo. So ng is the command line for it. I'm going to do a new command. I'm going to create a new project, and I'm going to call my project CLI demo. That runs off, and that goes and creates my project for me. You can see it goes through and creates all of those files. And then when I have a look at it in my IDE, we're using Visual Studio Code, you can see I've got a full solution here. The first time I did this, Angular was out well before the CLI, this took days of going through, following, looking at all of the different options out there for putting a solution together, wiring up your end-to-end tests to run, getting your unit tests to run, and doing a production build tool. This is days or a week worth of work that we just got out of the box. It was excellent. So now I'm going to jump back to the command line. I'm in my terminal. I'm going to change into that folder, and I'm actually just going to run ng-serve. So I'm going to run the serve command. That kicks it off, creates my bundles. I can open up my browser, and on port 4200, my app's running. Pretty nice. Literally only that much work. Let's say I want to go and write some code. So the Angular CLI has code generation. Now, we've all been promised code generation. So who got excited about MVC code generation when that came out? We've all seen it, and you never end up, it's, wow, that's great. Oh, it doesn't work, actually, for day-to-day life. We use this all day, every day. It's actually really, really great. So I'm going to create myself a new component, and I'm going to call it the home component. So I'm going to do ng-generate component, and I'm going to give it the name home. So you can see that's going to go through and it's going to create the CSS file I need, the HTML template, the spec file, which is the unit test file. It's going to create the component class itself, and it's actually going to wire that in to my app module as well, which is pretty nice. So I can jump into my IDE, and I can see underneath my app folder, it's putting in the home folder, and there's my component. So that's what we do, and then we jump in and start writing it's all spec'd out, and I can start adding functionality into my component. Here's the part about it that's amazing, though. So how easy it is to do a production build. So instead of writing a 900-line gulp file, I can now just go ng build, and if I just did ng build, it'd create me my dev build. If I pass it --prod, it's going to do a production build for me. And I can pass it the --AOT parameter, which is saying do ahead of time compiling. Okay? So on one line, it's going to go out, and that's doing all of those steps that Duncan went through. It's doing the tree shaking and the ahead of time compilation. It's generated my bundles. And now if I go in and have a look, it's actually compiled my whole application and put it in the dist folder. I can take the contents of this dist folder. You'll notice there's not 48,000 files there. You know, there's less than 10 files there. You know, you've got your fave icon, you've got the index.html, and then you've got the bundles of code. So there's no HTML templates there. They've all been taken and converted into highly optimized JavaScript. And that's what's going to be served as you navigate around your app. So I can take that and put that on my web server, and there's my Angular app. It's pretty cool. So I'll call out here. So if I go and take that and run it up in the browser, you can see down the bottom here, it's downloading 457K for the whole app. So that's pretty small, especially when you consider jQuery by itself is 256K. So this is Angular, the Forms module, RxJS, and the application. And the team's working on making it tighter. So the performance is great. A question we get asked a lot is the Angular CLI ready? And this was a real journey for us. We got a bunch of war stories around, what was the build tool to yield? We knew that Gulp was wrong, but then, we're faced with, well, there's Webpack, but it's complex, and there's CLI, but it's not ready. A lot of people went and investigated JSPM because it was amazing in the way of the future, but it never got the popularity. So there was a lot of churn and a lot of indecision about what people should be using. But we're really happy now because we feel very confident to tell people you should use the Angular CLI. If you're getting into learning Angular 2, this is the one that's going to get you off the ground if you're learning it really quickly. And for 95% of our customers, it's the right choice. Unless you know that you need customized build, and then Webpack's going to be the answer for you. So check out the Angular CLI, and if your project does need really customized build, then Webpack's the answer.
Cool. So let's talk about TypeScript and IDEs. You'd be surprised that there's a bunch of pain around this for a bunch of people. So one of the problems with large code bases that are in JavaScript is they can become unmaintainable. If you've got hundreds of thousands of lines, or you're like the Azure portal where they've got like 1 million lines of JavaScript, that can be pretty hard to maintain. And a lot of that's around the fact that there's no compile time checking. And it becomes risky to refactor. If you've got to refactor a variable across like 100 files, you don't want to be the guy or girl who has to do that based off string versus using, being based off symbol. So this is where TypeScript can really help. I'm not going to go into details about TypeScript. It's a type superset of JavaScript, and if you haven't seen it, you should go check it out. But it's the default language for Angular 2. But there's a couple of other choices that you could use, one of them being just vanilla JavaScript, ES5 or ES6, and Dart. But I haven't met anybody outside of Google who uses Dart, so we'll just focus on the TypeScript and the ES6 today. So why would you want to use TypeScript? There's lots of reasons. There's strong typing, but my personal favorite is the refactoring and the tooling. Like by far and away, the thing I'm most grateful for at work from day to day is Git and TypeScript. Git because I don't stuff things up, and TypeScript because I get to refactor without being as terrified. And also Angular's written in it. Actually, everything is written in it. So all the docs, all the courses, all the third-party libraries are going to be in TypeScript. So if you don't use TypeScript for Angular 2, it's going to be a fair bit harder. Now, I can't really think of any reason why you wouldn't use TypeScript for the reasons I've just said, unless you really had a strong bent for your team to just be staying with vanilla JavaScript. But you're going to work harder for it. And I've only ever heard one third-hand story of someone using JavaScript. Everybody I've met's used TypeScript. So another thing that's surprisingly painful for people is which IDE you use, and it's mostly around a single IDE that's caused the pain. So Atom's a good one. It's fast and it's lightweight. It's got a good plugin for TypeScript. It's pretty popular. Visual Studio is another one you could use, but surprisingly, it's not so easy to configure for Angular 2. There's been a lot of challenges with getting it to not throw errors on the new language features with the TypeScript compiler, getting it to work as because it's just a folder, it's not a solution, so getting it to work inside of Visual Studio, there's problems for people. I didn't find it too bad, but a lot of people have really not liked it, and we've been involved with a government project back home and they're building this awesome Angular app, Angular 2 for 34-inch monitors, and 3 front-end teams, and they said at the start, everyone has to use Visual Studio. And man, they still whinge today, even though they can now use whatever IDE they want about using Visual Studio, because they just had so much pain learning kind of Angular 2 and at the same time trying to battle with getting it to work with their IDE while they're getting their head around it. So that has led most people, and I think this will change, it'll come back around and Visual Studio will be fine, it'll get easier. But most people I've met who do C# on the back end now use Visual Studio Code for all their front end, and they use just Visual Studio for their C# on the back end, and they manage 2 IDEs. That's definitely the case in our office, and it's all voluntary, but that's been the case. So Visual Studio Code's one of the most popular ones. It's fast, it's lightweight, it's great for TypeScript, and it's got a whole bunch of plugins you can get, but you need to probably get about 10 plugins to make it really, really good. But the plugins are great. So you can get code completion in your HTML templates, which is fantastic. You'll get warnings when you've misspelled a variable in your HTML. You can right-click or navigate to the implementation of a function or a variable in the component class from the HTML. You can get auto-import statements while you're typing in your component class, which is great. So a lot of these kind of features are really, really help. So if you're doing Angular every day, this is a really good one. The other one that's really popular is WebStorm. All of those kind of Angular 2 benefits they just have out of the box without getting plugins. So it really comes down to choosing between these two. If you're going to write it day in and day out, these are kind of the most popular ones to use. So in summary for TypeScript and IDEs, you should be using TypeScript unless you've got a really good reason not to, which is not really many of them. And you want to keep your IDE using for the back end. Like if you're writing C#, I'd stay with Visual Studio, but I'd probably think about using Visual Studio Code or something like it for your Angular code, which if that's the first time you've heard that idea, you're probably going, I don't want 2 sets of keyboard shortcuts, that's crazy. But it's what most people are doing at the moment, and it's not too bad, especially because the keyboard shortcuts are kind of close. So another big pain has been around CSS frameworks and widgets, and it's actually a pain in the butt. So if you want to have a good UX, you want to have a good component library. Unless you love writing your own date pickers and accordions and those sorts of things, and maintaining the CSS across all the different browsers, and then when you want to extend it, you have to update all those things in all your tests. You want to be able to just get a component library for that. And when you've done 6 months or 12 months of using a component library in your project, you don't want to just pull it out and throw in another one willy-nilly, because that's going to be a bunch of work. So you've got to think pretty hard at the moment what you're going to use with Angular 2, and it's not necessarily lots of easy choices around that. So we really feel the choices between these two, between using Angular Material 2, which is components like drop-downs and so forth, and accordions, specifically made by the Angular team for Angular 2, and it's based on the material design specification. And then the other one is Bootstrap, which a lot of you would have heard and used, which since 2011 has been kind of the dominant way of doing HTML, CSS, and layout, and so forth. But there's a whole bunch of other ones. You've got PrimeNG, you've got Polymer, which is not necessarily anything to do with Angular, but allows you to get material-like components if you're going down the material road. There's NG Bootstrap, which was the most popular one in Angular 1 for Bootstrap directives, and it's going to be the most popular for Angular 2. There's Widgemo, there's Kendo UI, who are outside. There's DevExpress, they're also outside in the hall. There's Semantic UI, there's Materialize, there's Vaden, there's Velour, there's Fuel UI, there's NG Lightning. And there's another one. There's a whole bunch of them. But basically, they're all investing pretty heavily because they got such a good return from making all these components for Angular 1. But none of them are really fully complete or have been around very long or have all of the components from their other versions. So it's a bit of a pain at the moment deciding which ones you're going to use. And again, you're going to use them for a while, so it's a bit tricky. But they're pretty close, maybe a couple of months, and it's not going to be such a pain. So when you're deciding between Material 2 or between Bootstrap, which is kind of the choices we tend to make between, we think Material 2 is going to be the default. At the moment in Angular Material 1 is kind of the default for a lot of companies when they're making an Angular 1 site. There's full-time Angular members on that team, and they're moving pretty quick. They keep pace with Angular, and it's a first-class integration. So they're really high quality. The downside is it doesn't work with Bootstrap at all. So I had a student recently, and they're building like this project as part of their homework to make it in Material, and they thought they'd pull in a drop-down from Bootstrap, and the CSS clashes, and they think it's their code, but it's just a CSS clash. So it's, you're kind of going to choose one or the other. It's not like you're going to mix and match between these two. And it's still in beta. So they're moving really quickly, they've got heaps more components, they're very clear about this, but they haven't got all their components made. So there's no date picker, there's no accordion. So you definitely have experience with this as a pain. I went and redid all of our documentation for our course recently in polymer and material, and I couldn't get a accordion. All I wanted to do was just have an expanding list, and I had to kind of roll my own. And it takes an hour, but you don't really want to do that if you want to move quickly. You just want to grab some component and just use it. So that can be a bit of a pain. Bootstrap's awesome. I'm sure a lot of you have used it. It's still what we do a lot of our Angular 2 projects in. It's well proven. There's lots of component libraries you saw on that other list that are going to be supporting Bootstrap. And there's lots of non-Angular libraries that you can also use. So for example, we built an Angular 2 app for a client that's used to getting Kendo grids in their Angular 1 apps with us. I mean, I might not like the Kendo grids, but they love them. And they wanted to have it look the same, and they wanted an Angular 2 project, but there is no Kendo grids for Angular 2 yet, or they weren't ready at the time. So we just used the JavaScript version, which we could keep the Bootstrap styling from. So there'll be lots of kind of third-party small libraries based on jQuery and so forth that you might want to use that style with Bootstrap, and that can be a real benefit. But one of the downsides, it doesn't work with material. It's kind of a fork in the road, and you're going to have some sort of dependency on jQuery plus or minus jQuery, and definitely Bootstrap CSS. And a lot of people nowadays have a real bent against not using jQuery in their Angular code. They think you're terrible if you do, which is, I don't quite understand. There's lots of really cool libraries to use with jQuery, but I think a lot of people misuse jQuery with Angular 1, selecting the DOM directly and so forth. But these are kind of your choices. And you also got to watch out that you don't choose a third-party component library that's going to restrict you from using the AOT compiler we've talked about, because it's kind of all or nothing. If one of the libraries you use doesn't support it, you can't run AOT. So, and this will probably be only short-term, and a lot of libraries already support it, but you've got to watch out for that, that if you want to get that performance boost, then you want to make sure the component library supports it at the moment. So in summary for CSS widgets and frameworks, we think you should be using Material 2 and trying to patch the missing components with other ones around the place, like Polymer and so forth, and then you can kind of add them back in as they become available. Now, this is a pretty crazy idea and a bit ambitious, but it's the way we're trying to go down. A lot of teams are still going to be perfect using Bootstrap and have a very good clear path on that.
Cool. Let's talk about observables, RxJS and Redux. And this is where a lot of people find pain. They feel like sometimes it's a bit like this, The modern web apps are composed of asynchronous events, and asynchrony can be hard. You've got a button on your page, the button calls a HTTP request, all good, till a user comes along and goes, shoots off a whole lot of requests. You don't know how long they're going to take. You don't know what order they're going to return in. So async code can seem hard to write, hard to refactor, and hard to debug. The good news is that there is help. And if you use RxJS, it's really going to simplify it's going to simplify writing your async code. So what RxJS is, it's the JavaScript implementation of reactive extensions. So, and this is the part that a real area that we see people need to spend more time getting their heads around RxJS and getting a really good knowledge of it, because it's really an essential ingredient in Angular 2. So when you're doing any HTTP requests, you're returning an RxJS observable. When you're working with forms, you're using observables. And you can, there's RxJS is built in all the way throughout Angular 2. So I said that RxJS is the JavaScript implementation of reactive extensions. So reactive programming is all about applying the observer pattern to streams. So the thing that you've got to get your head around is you've really got to get the observer pattern, and then you've got to understand how that streams could work with it. So that's what I'm going to try and tackle today and just kind of get you on the right track. So the observer pattern works like this. Let's say that we've got an array, and that array is important to our UI. And when changes happen to the array, we want that to be reflected in our UI, but we don't want to do polling. Okay? What we want to happen is when a change happens, an event is we actually receive an event that says, hey, this has changed. Cool? So what we do is we set up observers. So I can create an observer and I can say, this observer is going to watch for when the number of items in that array changes. So I've got an observable with the array and I've got an observer that's watching it. So what happens then is that then when the number of items in the observable changes, an event is emitted. So then we emit the new value from that observer. What a lot of people miss is that you can actually have multiple observers for the same observable, each performing different operations. Cool? That's all the observer pattern is. So now we're going to take it to the next level, though, and we're going to apply streams to that pattern. So let's say we don't have that array up front. Let's say that instead of having that array up front, let's say that the values are coming in as a user hits numbers on a keyboard. Okay? So the user hits the number 1. A stream is emitted. We have the operator, the count operator for our observable, and a new stream is emitted from that count with the value of 1. So the user keeps tapping for 7. Okay? Because we've got multiple observers going on here. So when the 7 comes in, we're getting, from the count, we're actually getting a new value emitted of 3. From the where, we're saying we're getting a new stream that's emitted, which contains an array with the number 7 in it. So now, as we go along and new values are coming into our stream, we're getting new streams emitted from our operators with new values in them. Cool? They're the two fundamental concepts around reactive extensions. So let's have a look at what does that look like when we're actually writing RxJS in our application. So we've got a text box here, and we're going to do a type ahead. So a user can come along and they can type along in the box. This is kind of the canonical example. So that search field has a value changes property. And that value changes property is an observable that's going to emit the values that are coming into the text field. So what I can do to do a type ahead is I can apply the debounce operator. And so what that's saying is only emit a new value after 500 milliseconds of inactivity. And then I can apply the distinct until change operator. So only emit a new value if the value is different from the previous value. And then I can do the switch map operator, which is saying, take the stream that's being emitted, pass it through to my album search service, and then emit a new stream of HTTP requests. Okay? And the nice thing about switch map is it's going to cancel the last operation. And so that's how it actually, we're writing much more simple code when we're doing RxJS than if we were trying to handle all of that asynchrony ourselves.
Cool. RxJS is definitely a journey for sure. I've definitely found that process when you're doing it. You'll go off, you'll watch a small tutorial and you're like, oh, that makes a lot of sense. Someone gives you a perfect example like Steve-O just gave you, and then you go and you start doing it, and then you're like, oh man, I'm having a hard time getting this to work, and then you're trying to figure out how to debug it, and you're like, oh man, I don't got it, I don't think I get it. And then you'll go back to learning a bit more, and you'll come back to it, and then you'll start getting more ambitious, and you'll start be more declarative with the way you do things, like the type ahead you just saw, and then you'll be like, oh yeah, I got it, and then you don't got it, and then you've got to go back to it, and then you get more and more ambitious with it, which is really good, but every step that you get more ambitious with it is every step that you kind of crawl up this learning curve, and people actually draw like this cliff with people falling off it as a learning curve versus being like this roller coaster. So, but it takes time to do. You really got to commit to it. But I think with the Angular and our experience and the people we've worked with, because it's so baked into the way that you use it now, that every cent you invest in learning RxJS is worth it. It's not like you do all this learning and then you don't really get many benefits from it. So it really is a journey, and it's worth investing in.
So in summary, RxJS, the modern web is asynchronous, and RxJS actually makes it easy. So it takes some effort to fully understand, but it really is going to simplify writing your async code. And you need to spend the time because it's really baked into Angular 2.
Cool. So one of the other challenges in Angular 1 and still in Angular 2 is state management for any of these Angular applications when they get big. And it's always the code that I hate writing the most. It's always my worst code. It's the most buggy code. It's the stuff we argue on the most. It's the stuff that needs the most refactoring and the most tests. And it's just hard to do. And often when you've got an app that's got a lot of kind of state that's shared across a view, it's the stuff that's the hardest ends up being a big bowl of mutable soup, and it's not always the easiest, and it's the most expensive code we write for our clients. And this is where the Redux pattern can really help. So, Redux pattern is a predictable state management container that you can use. So I'm using Redux here with a little r, kind of referencing kind of the pattern of Redux, versus a big R, which is like the library from the React community for implementing it. So this all kind of evolves or revolves around this idea of having a store or a single source of truth. So it's just a single JavaScript object that maintains all the state in your application, be that, whether or not the state of the menu is open or closed, or whether or not you have, say, a companies array that you want to share around your application. So that all goes into the store, and the store is just read-only. And if you want to subscribe to the store, you can get that state and pass it down into the views. So imagine you have this idea of, the state has a companies array in it, and you've got 2 companies, and you want to delete one of those companies in your view. What you'd normally do is you just jump into your component, delete one of those companies from the array of companies, and then update the view. But in Redux, you wouldn't do that. What you'd do is you'd dispatch an action, because the store is read-only, and you'd dispatch an action, and then action would say delete this company, and the payload would be the company you want to delete. And this wording is very specific to Redux. And you'd pass that into reducers. So reducers are special functions, and they become the only place in your application where you change state. So you'd pass a reducer this action of delete company, and you'd pass it the payload of that company. And because state becomes mutable, you wouldn't just change that array. What you do is you'd make a new array minus the company you want to delete. And then you'd pass that down into the store, and you'd get this unidirectional data flow. So when you take this Redux pattern and you take RxJS that Adam's been talking about, and you take the Angular library and you mash them all together, you get this new library people are talking about called NGRX. So NGRX is a way of implementing the Redux pattern in your Angular applications, but also supercharging it by using RxJS and observables. So people talk about it like this. It's a bit outlandish that RxJS is a tool and a philosophy that will revolutionize your applications in your development experience. So this is kind of a crazy thing to say, and we always joke when we go to user groups that how do you know when someone uses NGRX? And it's usually because they'll tell you they're using it, because people get really excited about it. It totally changes the way you write your code. It's very, very different. So you'll never see a component with many injected dependencies. If you're used to doing Angular, you might see 3 or 5 or 6 injected dependencies into a component or a controller, like router and your services and logging and so forth. And you'll pretty much end up just injecting only the store into your components, so they get much more simpler, and you dispatch actions against the store, and you listen for events. You don't inject the router and other things, so things get really, really slim. And understanding, where your state change gets really easy, because it only happens in these reducers, nowhere else. So what would that look like in an application? So this is something we give our students to learn. It's a CRM application. We get them to build it with NGRX. So imagine you had that list of companies I was talking about. I just got 2 companies here, and I opened up the NGRX dev tools. So these dev tools is a big part of the experience and the reason you'd want to use NGRX. So you can see down here highlighted in red all of the dispatched actions since this application initialized. So the store was initialized, the router said that there was a location change to the default location of this company list, and this add companies action was dispatched. And then you can see the state of the application on this initial load is just, all it has is a companies array with 2 companies in it. So with these tools, I could go and click delete, and then that company would be deleted because it would dispatch an action of delete companies you can see here in red. And then the state would be updated, and now you'd have a new array of companies with 1 less company in it. So this is really good, and it kind of gives you a detailed view of what you can see. You actually get this log of everything that's happening in your application, and you can debug much easier, and you get this thing called time travel debugging. So if I was to click play down here and play back the state, and you can do this in these tools, then the first state you would see is that there is no companies. This is right at the very beginning when you're initializing your app. Then as it moves forward in the bar, then the companies now has the 2 initial companies. And then it moves to the next state, which was that you called delete, and now that there's only going to be the single company. So once you have this, then you can just go back and forth through your state. And every time you go back and forth, you can expand out the state and see exactly what was called, exactly the route change, exactly the objects in there. And you can see in what order and so forth. So dealing with async code gets a whole lot easier. So using NGRX, or should you not use NGRX, there's some pros and cons. You get easy state management, You get better tooling and debugging. You get a much simpler build. When you go through the code base, once you've wrapped your head around all the new principles, then it's much easier to kind of work with each component. You get performance benefits. You can implement something, a change detection strategy in Angular called onPush. So basically, you've got a section of that tree of components, and you can say to Angular, look, don't do change detection on this tree because I've got that covered. It's easier to test. Basically, you only need to test the reducers. And because they're pure functions, they take in a list of companies, they pass out a list of companies. Your test is basically just to test that. Because if you test the component, you're just saying, I'm testing that the store framework is working, and I'm testing that Angular is binding like the framework's meant to bind. So you're just really testing frameworky pieces. So a lot of people end up just writing end-to-end tests for everything and only writing unit tests for their reducers. So it changes the way you think about testing. And it's getting a lot of traction. Out of the last 3 big applications we've been involved in or reviewed, they've all gone down the road of using NGRX, mostly for performance. But it's another new thing you've got to learn. And if you're learning Angular already, you've got to learn the modules and RxJS and Typescript and a bunch of other stuff. It's pretty overkill for a simple application. There's definitely a bunch of boilerplate that you're going to end up writing around it to write all the reducers and the action dispatches and so forth. So if you only had 10 pages and none of those pages have much shared state on them, it might be a bit of overkill for you. It's another dependency, and this dependency has a big impact on the way you write your code and what your team need to understand. So your team, if you have a new team member come on and they don't know the Redux pattern, there's a bit of time for them to wrap their brain around it. And you're all in with RxJS. I think this should actually probably be a green dot because I really like RxJS and I'm kind of over that cliff, hopefully. You're all in. You're going to be thinking, you're going to run into situations where you're going to have to flatten out observable of observables. You're going to be combining 2 streams and combining them at the right time when one emits, not the other emits, and challenges like that, which is not difficult, but it takes time to kind of get your head around. So in summary for this section, we think that you should learn RxJS to simplify your async code. Not just learn it on the job. I think you should probably step back and actually learn some of the principles before you're just hacking through it and coding in all of the stuff as you learn it. We think Redux is great, but we think NGRX is amazeballs. And we think that you should use NGRX for your complex apps.
Awesome. So where to from here? Well, we're running a 2-day workshop at NDC Mini in Copenhagen on the 22nd of February, so maybe I'd like to see some of you guys there. We've written a book, so come and grab a free copy of our little book of Angular 2. Don't forget to vote on the way out of the room. That's the colour that you're chasing. So in summary, what have we looked at today? We've looked at what is Angular 2 and why you should care about it. We've looked at strategies for upgrading your Angular 1 applications and the fact that if you're writing Angular 1 is adding technical debt. We've looked at the choices around module loaders and build systems and the fact that that's one of the big areas you've got to get your head around. We've seen how TypeScript is going to help us. We've had a look at the best choices for IDEs. We've looked at the decisions to make around CSS frameworks and widgets. We've hopefully given you, introduced you to RxJS and emphasised how important it is to learn and said how great Redux is for writing large, complex applications. Guys, thank you very much for coming along. Follow us on Twitter and hopefully we'll see you around the conference.